Okay, I'm hoping that we can take a look at problem number 2 on lesson 21 in chapter 3. This is in my book, it's on page 117. It should be pretty close in yours. And you have the your turn to play problems to do for this lesson, but I want us to do this one together because this is nothing like you've ever seen before and probably won't see again until you get to geometry. So he's asking us to prove this statement, right? Which I would say we already know to be true. It says -4 times -9 is the same as or is equal to 4 times 9. Now, I just want to talk about proofs for just a second because this is the first proof ever that you're doing. So when you do a proof, think about a proof meaning like a convincing argument. And probably the most relative thing I can give to you in your life at this point is trying to convince your parents that you need to do something or that you should be allowed to have something. You make a statement, all right? I should be able to stay up late tonight and watch this show. And then you proceed to give a reason. The reason cannot be an emotional reason. The reason has to be factual. So for example, you might say, I think I should be able to stay up and watch this show tonight. And then your reason might be something like, I have been really good about getting all my homework done. And so that would be a factual thing that would justify why you believe that you should be able to do something. You might then say, they might push back and say, you know, no, you can't do it. And you might also say, you know, I've been setting my alarm every morning and getting up, and you have not had to come in and wake me up. So you're making a statement and then you're justifying it with a reason. And in math, we do the same thing. We make a statement and then we give a reason that is not based on, I think that's the way it should be, or I'm pretty sure we've done it that way before. It's something factual, right? There is a mathematical reason. And so Fred has outlined this proof for us. He's given us all 5 of the statements in the proof, and we have to give the justification. Why are we allowed to say this? All right, so he has, in fact, I'm hoping that you'll be on, print out that page 117 and have it right next to you. But on that page, I just couldn't fit everything on this one. On that page, it gives a list of reasons that you could use, kind of like when you use a word bank, like when you're doing definitions or whatever. You're trying to match a definition and a word. It gives you the selection of words and you have to match it up. So kind of the same thing here. We're not going to use all of them. The list here, let me see if I can get it under here. I probably can't. No, I can't. Symmetric property of equality, reflexive property of equality, 0 times anything equals 0, the distributive property, any number subtracted from itself is equal to 0, and 0 plus any number is equal to that number. So we've talked about all of these, well, most of these fairly recently, the symmetric property of equality, reflexive property of equality, and distributive property. The other ones hopefully are pretty obvious to you. 0 times anything is 0, any number subtracted from itself equals 0, and 0 plus any number is equal to that number. Actually, that last one is the additive identity. The addition, yeah, I can't remember exactly what we called it. The addition property, I think it's the identity property for addition. Okay, 0 plus any number is equal to that number. It preserves the identity. Okay, so we're just going to go through here. And again, I'll kind of explain what he's doing here, and then we'll talk about the reason. All right, so for the first statement, this is a whopper. You will look at this, I'm looking at this, and I'm thinking, why on earth did he ever choose this as the first statement? Why did he choose to write 4 times 9 plus 4 times -9 plus -4 times -9 in the first place, and then set it equal to the exact same thing? The reason is quite simply because it works in helping us do this proof. As you do more math, you'll realize sometimes you just kind of have to play around with it for a while, realize what works, and then this is kind of the finished product of all your struggling, all of your work that you're thinking about. So he probably played around with this for a while and realized that this would work, and so that's his first statement. What we're trying to do is not understand why he wrote this part, all right? Again, it works for him. But what about math do we know that makes this first statement true? 4 times 9 plus 4 times -9 plus -4 times -9 equals exactly the same thing. And again, hopefully you're looking at that list on page 117 and going through and thinking about those properties that we've talked about. All right, again, symmetric property of equality. Remember, said, I'm going to just jot some notes up here. Symmetric property said if A equals B, then B equals A. Well, that's not what we have, because we don't have two different things on the equal side, on the different sides of the equal sign. We have the same thing. The next one, reflexive property, says something equals itself. Right? Actually, as I'm looking at it, that is exactly what this looks like. Here is our A. It is a crazy, fancy A. And here it is, again, the exact same thing. And again, we talked about that reflective. You should think reflection. You're looking at exactly the same thing. This kind of equal sign is acting as the mirror, and you see it on both sides. So this is the reflexive. Sorry, this is going to be hard to get around. R-E-F-L-E-X-I-V-E. Property of equality. Okay. The next line. Now our job is to try and figure out what happened from here to here. How is this part right here different from this? How is this different from this? So as I look through, I see things that are the same. That has not changed, but this has changed. It was 4 times 9 plus 4 times -9. It is now 4 times 9 minus 9. Same thing over here. This part stayed the same. But this part right here, the 4 times -9 plus -4 times -9 has changed into -9 times 4 minus 4. And we go through and we look at our list of properties. It's not symmetric, all right? It didn't say two things are equal to each other, therefore the reverse are equal to each other. It is not reflexive property because we don't have identical things here anymore. It is not 0 times anything equals 0. I don't see any zeros in here. Distributive property is the next one that we get to, and I think, there are parentheses. That does make me think of distributive property. Now let me look, all right? So I started here, and I had 4 times something plus 4 times something else. Usually that's what we get after we distribute. So is it possible that this is essentially undistributing that 4? All right, this is saying what it was before it was distributed. Well, if it were, then we would have to pull the 4 back out to the front like this, and what would be left are the two things that we distributed it to. 9 minus 9. Yes, this is actually undoing the distributive property. So it's just distributive property in reverse. All right, and then let's check to see that this is the same thing over here. So 4 times -9 plus -4 times -9. Again, this is the thing that was distributed because it's in both terms. Right? So yes, they pulled that out, even though it was on the right side instead of the left side, like it was here with the 4s on the left side. This is still distributive property because, again, remember, multiplication is commutative, so we could have written it with the -9 first. All right, so then we're going to undistribute that -9, and what's left here is the 4, and what's left here is the -4. All right, so this is because of distributive property. Okay, in the next one, again, we're going to look to see what is the same and what's different. So just like before, this -4 times -9 remained the same. He did nothing to that. This 4 times 9, he did nothing to that. That stayed the same. But these two things have changed. And we've gone from 4 times 9 minus 9 to 4 times 0. We've gone from -9 times 4 minus 4 to -9 times 0. So again, we're going to look through the list. No, it's not symmetric property. No, it's not reflexive. Again, it can't be reflexive because it's not showing identical things on both sides. It's not 0 times anything equals 0, because although we do have a 0, and we should consider that, it's not telling us, we're not multiplying at this point to get 0. What happened was we did 9 minus 9 to get 0, 4 minus 4 to get 0. It's not distributive property. The next one, any number subtracted from itself equals 0. Yes, that's what happened. We took 9, we subtracted 9, so we subtracted 9 from itself and we got 0. Here we subtracted 4 from itself and got 0. So any number subtracted from itself sorry, I'm running out of room here and I'm hitting my leg on my tripod. Anything subtracted from itself is 0. Okay, the next one. So now again, we're going to go through, we're going to see what stays the same, what changed. This still remaining the same. This still remaining the same. What's changed is these two terms right here. It was 4 times 0, it's now 0. It was negative 9 times 0, it's 0. So why can we say that 4 times 0 is 0? Why can we say that negative 9 times 0 is 0? Well, that would be the one that we skipped over before. 0 times anything equals 0. So here we're saying 4 times 0 is 0. Yep, that's what we got. Negative 9 times 0 is 0. It's because anything times 0 equals, well, I'm not, right? Again, these are all things. I ask you questions in class and I say, why do we know that's 0? Well, because 0 times anything is 0. That is a justification that we are allowed to use to prove that we know something. All right, so anything times 0 is 0. And then finally, this last step right here, what has stayed the same? This negative 4 times negative 9. What has changed? Well, I'm sorry, and also this 4 times 9. What has changed? That 0 plus and the plus 0 are gone. So really what we're doing is we're saying that these two things added together equal that. These two things added together equal that. Why is that? Well, this would be the additive identity, or we just say, his suggestion here is 0 plus anything is equal to that number. So 0 plus any number equals 0. Oh, sorry, nope, doesn't equal 0. 0 plus any number is equal to that number, or equals that number. Again, you'll have a little bit more space than I did, so you can write these out a little bit longer. And all you're going to have to write in your notebook is just the reasons, although it probably wouldn't be a bad idea to copy down that proof. So, okay, if you have any questions on this, if something's just not making sense to you, make sure you let me know. Bye.